Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 12, Multiple Choice, question number 29. A thin disk of radius r is held closing the opening of a thin hemispherical shell of the same radius. Both the bodies are made of insulating materials and have uniform charges of surface charge density sigma on each. The plate is released, keeping the shell fixed. How much maximum kinetic energy will the plate acquire after it is released? So there are four choices, and we have to select the correct option after solving it. So let us solve this question. All the data has been collected here, like a thin disk of radius r is held closing the opening of hemispherical shell of radius r. So this is the hemispherical shell. Both hemispherical shell and disk are of insulating material. Hence, hemispherical shell as well as the disk is made up of insulating material. And this hemispherical shell and disk has a uniform charge sigma on its surface. In this diagram, this is the hemispherical shell and it is open here. On the cross section, it is open. There is no disk shown here. So basically what we are doing, we are assuming a spherical shell charged uniformly over its surface. Complete spherical shell. Means join these two together. Charge, we have taken it as positive. We know that in the complete spherical shell, when it is joined together, the electric field intensity inside at any point inside the spherical shell will be 0. Now we split up the spherical shell into two halves, one this, one this. And we have taken the point A on the cross section, assuming that one component of the electric field is working, is in the perpendicular direction of the cross section, and one component is parallel to the surface of the cross section, as shown here in this diagram. The second half, which is identical to first half, will also be having a point corresponding to it, and it will also be having the electric field on this second half will be the mirror image of what is there on the first half. So when we combine these two together and superimpose these electric field vectors, we can see that the component perpendicular to the surface is cancelling out each other, but the components which are parallel to the cross section's surface is adding up. It means when we combine these two to make a complete spherical shell, there will be a residual electric field inside in the parallel direction. But in actual, we know that there is no electric field inside a spherical shell, and it is 0 always anywhere inside the spherical shell. So therefore, it can be concluded that in the half of the spherical shell, the electric field only be in the perpendicular direction at its cross-section surface, and the surface is equipotential. Now this diagram is showing the hemispherical shell closed by the disk. This gray color is the disk. Since all the charge on the spherical surface is r distance away from the center, the potential due to the charge, entire sum of charge on the center, C will be, we know that KQ by R. Q is charge density into area, so that is 2 pi r square by R. So we are getting it as sigma into R by 2 epsilon naught. The cross section of the hemisphere is equipotential, hence the total potential energy stored in the system, including the disk and the shell, is potential V into charge on the disk. D stands for disk. So V we have calculated, we have already equated in the last page. So we will put this value sigma r by 2 epsilon naught into the QD. QD is the charge on the disk. That is equal to sigma is the charge density into area of the disk, sigma pi r square. So we have got this expression pi r cube sigma divided by 2 epsilon naught. So this total potential energy will transform to kinetic energy when the disk is infinite distance away from the hemisphere, where the potential energy will become zero from energy conservation. There is no dissipative force working. So all the potential energy will be transformed to kinetic energy when the disk is infinite distance away from the spherical shell. So it means the entire potential energy will change to the kinetic energy. So hence maximum kinetic energy the plate disk acquires is the same, equal to the total potential energy of the system. So our answer will be C option. So hopefully you understood the concept behind it. In case any doubt, please do write in the comment box. I will explain on that. Thank you.